All right, thank you so much for joining us. And this is the review version for 2024, and the questions are so interesting. All right, so let's jump right in. So the question is asking us to compute the values of t, where the instantaneous velocity of the object is. So the word here is 4, right? So they've given us the function s of t, which is equal to t squared minus 60 plus 10. So since we are talking about the instantaneous rate of change, then we need to find s prime. So s prime is going to give us s prime of t is going to give us, use the power rule, 2t minus 6. When I differentiate the constant, it's going to be 0. But we are saying that the instantaneous rate of change, or the instantaneous velocity, is 4. So this is equal to 4. So I'm going to have 4 is equal to 2t minus 6. So this is what I'm going to get. So 2t is equal to 4 plus 6. 2t is equal to 10. And my t will be equal to 5. So I just place my final answer here. T is equal to 5. So that is basically what we just need to do here, because it's saying that it's 4. Now let's look at question 2. Now they've given us a piecewise function, and then the question is, for what value of a is a function continuous at 1? So we just want to find the value of a such that the function is continuous. So if the function is continuous, then it means that when you plug in the function, it exists. The limit from the left and the right exists and is equal to the actual limit. So since this one is using less than or equal to, then we are going to use the limit from the left and then limit from the right. So pay attention. Anytime you are having something like this, we use limit from the left and then the right. Let's assume that this one was something like x is not equal to 1 and s is equal to 1. If you have something like this, you don't use the limit from the left and from the right. You are going to use the last property, x is approaching 1 of f of x should be equal to this. So this is, anytime you see something like this, you go by this. But anytime you see something like this, then you go by this. So this one is go by this. Limit x is approaching 1 from the left side of f of x should be the same as limit x is approaching 1 from the positive of f of x. So pay attention to this. Anytime you see something like this, use this to prove or look for the constant that you are looking for. And anytime you see this one, you use this to solve. So now let's use this. So from the left is the one that x values are less than 1. So we are going to use this. So we are going to have limit x is approaching 1 from the left, 3 minus x squared, and it should be the same as limit x is approaching 1 from the positive side, ax plus 4. So I'm going to set x is equal to 1, x is equal to 1, and I'm going to have 3 minus 1 squared is equal to a times 1 plus 4. 3 minus 1 is equal to a plus 4. Then 2 is equal to a plus 4. A is equal to 2 minus 4, and a should be minus 2. So when a is minus 2, the function is going to be continuous at x is equal to 1. So a is equal to minus 2. Right. Now let's look at question 3. Now question 3, we just want to take derivatives. So I said some of the derivative we need to simplify. So this is also the same as 6 x to the power 1 over 2 plus e to the power 3x plus pi to the power 3. So now let's look for f prime. So f prime of this will be equal to 6. Let's use the power rule for this, and we are going to have 1 over 2 x to the power, subtract 1 and have minus 1 over 2, plus differentiate what is on the top and have 3 and multiply it by the whole function. Then when I differentiate this is a constant, so I get 0. So this is going to give us 3 e to the power, x to the power minus 1 over 2 plus 3 e to the power 3. Now pay attention. When this, I didn't just brought this 3 here. No, not this. I differentiated the top so that when you have e to the power x squared, then this is going to be 2x e x squared. So what did I do to here? I differentiated what is here. So 2x. When you differentiate this, you get 3 of that. So pay attention to that one. Now this one, I'm going to use the product rule. So I'm going to assign a to be 2x cubed and b to be equal to cos of 5x. So a prime using the power rule is going to give us 6x squared. Then what is b prime? B prime is going to be, when I differentiate cos, I'm going to have minus sine of 5x. Don't forget, we are going to use the change rule here. So I need to multiply it by differentiating what is inside, which is u. So this one is like, I'm picking cos of u, and then u is equal to 5x. So b prime will be equal to minus sine of u times u prime. And here u prime is equal to 5. So it means that b prime will be equal to minus sine of u is 5x times u prime is 5, which is the same as what I had here. I can simplify this and have this one to be minus 5 sine of 5x. So now let's now finalize f prime of x using the product rule. So this is going to give us just this times this, and then this times that. Then we are done. Right. So let's do that. So I'm going to have this times this, which is going to give us 6x squared cos of 5x plus 2x cubed times minus 5 sine of 5x. I can simplify the last one here and have cos of 5x. Then this will be minus 10x cubed sine of 5x. So that's what I'm going to get. So you see that when I was doing this, I didn't use something like this. I didn't do like dot. When you do some dot here, this one is like looking like this minus that. So it's good to make use of the parentheses, right? So that when you finish, you multiply and you have something like this. Okay. Now let's look at this one too. This one we are going to use a quotient rule. So let me have my u at the top and v at the down. So I'm going to have f prime using the quotient rule is v u prime minus u v prime divided by v squared. So here now u is equal to 2x and v is equal to 1 plus secant x. So what is u prime? When I differentiate 2x, I'm going to have 2 v prime. When I differentiate 1, I'll get 0. But when I differentiate secant, I'm going to get secant x tangent x. Secant x tangent x. So all I just need to do here is just do substitution. So v is 1 plus secant x times v prime is 2 minus u is 2x times v prime is secant x plus times tangent x, all divided by v squared, which is 1 plus secant x all squared. So very simple from here. We don't need to do any simplification here. So we can just leave our final results just like that, and then we are done. Let's look at D. So D, we want to use the change rule, right? So what I can do here is I can say that f of x is equal to tan of u, and my u is equal to x to the power 3 plus 2x. So f prime will be equal to, remember the function is in terms of x. So based on the change rule, this is going to be secant squared of u times u prime. Then if that's the case, then now I need u prime. What is u prime? U prime is equal to 3x squared plus 2. So it means that now my f prime itself is secant squared, u is x cubed plus 2x times, put this one into parentheses and have 3x squared plus 2. But mind you, you can just do it straight from here, right? And say that, okay, f prime of x is equal to, when I differentiate tan, I'm going to get secant. So secant squared, then you don't touch what is inside the parentheses, then you multiply it by the derivative of what is inside, which is 3x squared plus 2, which is the same as this. So any way that you pass, you get it right. But the idea is that you do it the right way that you think is comfortable for you to get it right. All right. Now let's look at question 4. Now question 4, we want to find the, derivative f prime using the limit definition, right? So this one, if I want to, do something and see what I'm working towards, then I can do, fast differentiation. F of s here is the same as 1 plus 5x to the power 1 over 2. So let me differentiate this and see what I'm going to get. So f prime of x will be 1 over 2, 1 plus 5x. You don't need to do this, but I'm just doing it, right? But you can do it so that you can verify. Then I differentiate what is inside. I'm using change rule, so times 5. So this is going to be 5 divided by 2, 1 plus 5x to the power 1 over 2. So it means that when I differentiate this, I should be having 5 divided by 2 square root of 1 plus 5x. So if I have this one, this is basically what I'm going to work towards. And at the end of the day, this is what I need to get. So I just did this so that I know that at the end of the day, this is what I'm going to get. But this is not the right procedure, because even the question is saying that in order to receive a credit, you need to use the limit definition. So if we just paste this one here, this is wrong. So now let's use the limit definition. What is the limit definition? We know that f prime of x is equal to limit h is approaching 0, f of x plus h minus f of x all divided by h. So this is the limit definition. So we need our f of x plus h, given that f of x is this. Now this is what I advise for you to write f of x again by making sure that since this one is in parentheses, you put all the x in the function into what parentheses. So this is the same as 1 plus 5x. Now this one helps us to now find for f of x plus h. What am I going to do here? I'm just going to replace all the x in the parentheses by x plus h. And when I do that, I'm going to have x plus h is equal to square root of 1 plus 5x plus h. So what did I do? Compare this to this and this to this. You see that the only difference is this is x, this is x, this is x plus h, and this is x plus h. So putting all your x's in parentheses helps you to now write out the f of x plus h. If you don't do that, then you see that it's going to be so kind of like complicated, and then you don't know what to do. Now that I have my f of x plus h, now I can try to simplify, right? So let me say that this is the same as square root of 1 plus 5x plus 5h. Now I can decide to look for f of x plus h minus f of x, which is just going to be square root of 1 plus 5x plus 5h minus, so this is f of x plus h, and then f of x is this. So square root of 1 plus 5x. Now, I can find a conjugate here, but because this one is in terms of square root, I can decide to place this one here and then find a conjugate, or I can just do the conjugate here. It's any of them is right. Any of them is okay. So let me use this one direct because of the root. So let me just use it direct. So f prime of x is equal to limit h is approaching 0. Then the whole of this is equal to this. So I'm going to have square root of 5, 1 plus 5x plus this minus square root of 1 plus 5h, all divided by h. So what I need to do is I need to find the conjugate. So I'm going to multiply this one by square root of 1 plus 5x plus 5h plus square root of 1 plus 5 divided by the same term again on the top. So divided by square root of 1 plus 5x, 5h plus square root of 1 plus. So what did I change here? I just picked this and change the sign in between them to positive. Here, here, and this one is like you are multiplying the function by 1 because this cancel this and you get 1. Let's try and simplify. Now, note that if I have a times a, this is equal to a, right? So square root of a times square root of a is a. So it means that if I see something that are the same and they have square roots, it's equal to one of them under the root, right? So this is the same as this is the same as limit h is approaching 0. Now this times this is 1 plus 5x plus. Now one thing about conjugates is that when I multiply this by this and multiply this one by this, they are going to cancel out. This is only for conjugate when the function here is the same as this, the function here is the same as this, and the sign is positive and negative. For example, if I have x plus 1, x minus 1, this is also conjugate because I have x, I have x, I have 1, I have 1. The only thing that's changing is the negative. So I can say that this is equal to x squared minus 1. What did I do? I just multiply this one by this and multiply this one by this. That's all. I don't need to multiply the middle one because they are going to cancel out. So that is conjugate. So it means that I don't need to worry myself doing this times this and this times this. They are going to cancel out. So I just need to multiply this by this. And I'm going to have minus 1 plus 5x. So you see that this is in the parentheses. If you don't do that, you might get it wrong. Then the denominator is going to be h in parentheses square root of 1 plus 5x plus 5h minus square root of 1 plus 5 plus 5x. So this is what you are going to get. So let's try and simplify this. Limit h is approaching 0, then 1 plus 5x plus 5h minus 1 minus 5x divided by h square root of 1 plus 5x plus 5h then plus square root of 1 plus 5x. Now this is the same as limit h is approaching 0. Now this will cancel that and this will cancel this. So as I told you, anytime you are finished simplification, the numerator, which is the top, should like the rest should be in terms of only h when you cancel out. So you see that what is left is 5h all divided by h, 1 plus 5x, 5h plus square root of 1 plus 5x. So now what we are looking is now here, h will cancel h, and I'm going to have limit h is approaching 0, 5, then I'm going to have square root of 1 plus 5x, 5h, square root of 1 plus 5x. So now I can set h to equal to 0. And when I do that, I'm going to have this now to be equal to 5 divided by, when I set h to be 0, this one will go to 0. So I just going to have 1 plus 5x plus square root of 1 plus 5x. Because h is 0 and this one will be 0. This and this are the same. So it's like a plus a is going to give us 2a. So this is the same as, let me shift this one small. So this is the same as 5 divided by 2 square root of 1 plus 5x, which is what we had here, right? 5 divided by 2 square root of 1 plus 5x. Yeah, so I use the change rule here to make sure that when I solve it, I'll be able to confirm whether I'm getting it right. If not, then I need to go through and check if there is negative or positive that I interchange. Yeah, so that's question 4. Now let's look at question 5. Let's look at question 5. Use implicit differentiation to find the equation of the tangent line. So what is the equation of the tangent line? Let's write that one well. So this does not involve f of x. So I'm just going to write it this way: y minus y1, which is equal to dy over dx, x minus x1. So I write it when, if the function given to me is in terms of f of x, then I prefer using y minus f of x1, which is equal to f prime of x1, x minus x1, right? So I change this one to f prime of x1 and I change this one to f1. But there's no f here, so I just need to use this. Now, as I said, anytime you are dealing with the equation of the tangent line, the point given to you, 1 and minus 1 here, is x1 and y1. So it means that this will be y minus 1, and then dy over dx, x minus 1, and y plus 1 is equal to dy over dx, x minus 1. So we're almost done with the equation of the tangent line. What we need right now is dy over dx, which we can get it from here. Good. So now let's come here. X squared y cubed plus 2x squared is equal to y plus 2 at the point 1 and minus 1. Now, when we are coming to look for the slope, now the point changes from x1, y1 to, now this is x and this is y. So pay attention to that. Then, since I'm taking the dy over the x, I need to take d over the x on this side, and then take d over the x on this side too. So this one I need to use the product rule. So I can say that a is equal to x squared and my b is equal to y cubed. So a prime is equal to 2x, and then b prime will be equal to 3y squared, but don't forget to multiply it by dy over the x because of the chain rule there. Good. So it means that when I differentiate this using the product rule here, I'm going to have 2xy cubed, that is this times this, and then this times this is going to give us x squared times 3y squared dy over the x, plus, then I need to differentiate this using the power rule. So when I do that, I'm going to have 4x, which is equal to, when I differentiate y, I'm going to get dy over the x, and when I differentiate 2, it's going to be 0. So we are done. Now, as soon as we are done differentiating, we just need to use our point, right? So let's make use of the point. So 2 times 1 minus 1 to the power 3 plus 2 1 squared times 3 times minus 1 squared dy over dx plus 4 times 1 is equal to dy over dx. So this one will help us to simplify. So minus 1 to the power 3 is minus 1. So this is going to be minus 2. Then minus 1 to the power 2 will be positive. So this is going to be 3. I'm going to have 3 dy over dx plus 4 is equal to dy over dx. So let's group items. This guy with this guy is going to be 2. So I'm going to have 2. Well, let me say this plus 4, and then dy over dx minus 3 dy over dx. So this, what this is here, and move this one here, getting the minus. So this is going to give us 2, which is equal to, this is 1 of dy over dx minus this. So this is going to be minus 2 dy over dx. Then when you divide through by minus 2, this implies that dy over dx is equal to minus 1. So now we know that dy over dx is equal to minus 1. So let's write our equation. We are going to have y plus 1, which is equal to minus 1x plus, I think, x minus 1. Is that right? Yes. So we just replace dy over dx by minus 1, and we have the equation of the tangent line right there. Now let's look at question 6. Use the graph of f of x given below to answer the following questions. So for which values, or for which x values does f prime is equal to 0? So f prime is equal to 0. We are talking about the slope of the tangent. So that's where we have the minimum and maximum. So it can be here at the turning point, here too at the turning point, and here too. So the x values are the one here, the x values, and the x values are also one here, right? So the x values are x is equal to minus 1, 1, and 3. Good, very simple. So turning point, turning point, turning point. Then you trace it to the x value. You trace this one to the x value. You trace this one to the x value. Now state the interval where this is increasing. So this is greater than 0, meaning that increasing, and this one too is decreasing. So looking at how the function is, I'll just do something before I just give you the interval, right? So looking at this line, we have minus 1, we have 1, and we have 3, right? As we can see here, minus 1, 1, and 3. So from minus 1, we see that there is a decrease here. So we are going to just decrease. So that is f. F prime is minus. Then we increase here. So this moves up. And then f prime is positive because it's increasing. Then we are going to also decrease here. So this is going to decrease. And we are going to have, decrease, and we are going to have minus here. And then we are going to increase from here, which is going up, and we are going to have positive here. So now what will be the interval for f prime of x to be greater than 0? So anything greater than 0 is positive, right? So this is negative, this is negative. So these are for when x is this. So positive here, right? So the increasing interval is going to be minus 1 to 1 union from 3 to positive infinity. Then f prime of x will be less than 0. The ones with negative, so decreasing here and decreasing here. So we are going to have from minus infinity up to minus 1 union from 1 to 3. So that will be the increasing and decreasing interval. Now we want to sketch the graph for f prime. Now this is what you need to have in mind. How many turning points? We have 1, 2, 3. So this is kind of like, we can say that our f of x was like the leading coefficient was s cubed, whether positive or negative, we don't know. So it means that if I want to find f prime, then the degree is going to reduce to x squared. So it means that in the f prime graph, our turning point is going to be 2, just 2, not 3. So that's one thing that you need to have in mind. Now, this is a strategy that I learned from, anytime you want to sketch a graph, which is like not a linear function or not x squared, for you to just, know how the thing is. So I'm going to just cut this out, right? So when I cut this one out, it will be left with this turning point and this turning point. Then I'll shift this one unit. So that's basically what is going to happen here. So I just cut this point out so that I'll be having this, which is like quadratic because I'm differentiating one side. Then I'll shift this one unit here. So that's basically what is going to happen here. So let's see what is happening here using this so that we can basically sketch the graph nicely. So we can see that the graph is decreasing here. At minus 1, f prime is minus. So let's look at this one here. So we are going to have minus 1, we are going to have 1, and we are going to have 3 from the critical values here. Then at minus 1, we see that it's minus, so it's kind of like decreasing this side. So we are going to have something decreasing from here going down. Then in between minus 1 and 1, the function is increasing. So now let's see what is going to happen here. So function is going to just increase this way. We don't know where it's going to tend. So like we are going to have something like this. Then from this side to the function is decreasing up to this. So that one too, we are going to have something like this. And then from here is just moving up, and then we are going to have something like going up. So you see that now we are having two turning points. We have one turning point here, we have one turning point here. Now this is 3 turning points. And if you look at the graph that we just drew, you see that we have decreasing kind of here, and we have this one kind of here, and we have this one kind of here. So it's kind of like this guy is gone, and we've shifted this graph to make sure that this is at 1, minus 1, and this is at 1, and this is at, you get it here, kind of something like that. So this is how the graph should be looking like. So we are going to have something like this, something like this, and then we just move like this. So the turning point should be 2 because we are differentiating something that is having 3 turning points. So it means that when we differentiate it, we need to have 2 turning points. So that is the idea with sketching, f prime graph, right? So if the function is like, for example, if I take f prime prime of this, if I want to find f prime prime of the turning point is going to be 1 because this is now having turning point 2. So I'll cut this one out and it will be left with this. Then when I go to f prime prime prime, then it's just going to be, so it's just going to be one linear function like this, just a linear function because it's going to be a constant. Okay, let's look at question 7. Now, draw a graph of the function this that is defined everywhere, continuous everywhere, except x is equal to minus 3 and 1. Except x is equal to minus 3 and 1. Okay, so now let's see. We know that except minus 3 and 1, it means that it can either be a horizontal asymptote, a vertical asymptote, or a jump, because when the function is not defined, it's kind of like a jump, or let me say, something like that. So now let's try and sketch what we have here. So I love these questions because this is like very simple to sketch. So 1, 2, 3, 4. So this is very simple for me to sketch here and say that this is 4 and this is 1. So 1 here, 4 here. It's very simple. So I don't really bother myself working with that. Now we see that this is 3. Limit as x is approaching 1 is 3. There is something that is telling us. It's telling us that limit as x is approaching 1 from the left of f of x is the same as limit as x is approaching 1 from the right of f of x, and they are also equal to 3. Because for us to conclude that this is equal to 3, then indeed the left and the right is the same. So at 1, this one here, we are having 3. 3 is somewhere here. So at 3, we will see that this is going to be a hole because we are on the same line and this is open. So this is closed. So now on the left, on the right. So from the left, we are approaching 3, and then from the right, we are approaching 3. We are going to have something like this here. So we are done with this one too. Now, this is f prime, so we will come there later. But let's look at something here. X is approaching minus 3, and we are getting to negative infinity, right? X is approaching negative 3 from the positive side. So we are going to have 1, 2, 3. So minus 3 is here. And when we are approaching minus 3 from the positive side, we need to be going to negative infinity. So if this is minus 3, when I'm approaching minus 3 from the left, I should be going to negative infinity. Sorry, from the right. So that is for this one. Then when I'm approaching minus 3 from the left, I should be getting to 1, right? 1. So it means that this is 1 here. So from the left, I should be getting to 1. So this is, I have some tail here. So I can call this one a vertical asymptote because the right is just not attaching this. So this one is going to be like vertical asymptote. So I'm done with this one too. Then the function is saying that if x is approaching negative infinity, we should be going positive infinity. Okay, so this is going to approach negative infinity, but we need to move positive infinity. So it means that this is going to be something like this. As we are approaching negative infinity, we should be going positive infinity with this for this. So now we are done with this, that the only thing that is left is this guy here. So we will find out what is happening there. So now let's find out here. F prime of 1 is minus 1. When x is approaching, when x is greater than 1. So this is like, I can think of this one as, let me say, limit as x is approaching 1 of, let me say, f of x, this is equal to minus 1. Yes, this is true. This is true. Because this is f prime, so we are thinking of the limit definition, right? So x is approaching 1, and this one should be this. So it means that kind of like we have a horizontal asymptote. Yes, it's kind of, we have horizontal asymptote here. When we are approaching this, we should having minus 1. So minus 1 here, and then kind of like we have horizontal asymptote here. So when we are approaching 1, is that true? No, it's not. Basically, we are approaching 1. I think when we are going to infinity, I think so. Because x is greater than 1, so this should be getting to infinity. Yeah, I think this is true. Like x is greater than 1, so s can be 2, 3, then we are going to positive infinity. So I think this one should be positive infinity. So it means that when we are moving positive infinity, we should be approaching 1. Yeah. So this right hand here should be going this way. And we can join these people two together and have something like this. Good. So we've gotten a great graph. Good. So should have it something like this, which is not bad. Good. So I think, yeah, this is what they are going to get for this graph. So like sketching graph is kind of like you have some technique, and then you make sure that you look at it, and then you just draw them point by point, or yeah. Now let's look at question 8. We have, after this one we have 2 more to go. Now the population of a small town is given by P is equal to f of t, which is a function, and t is years since 2000. Suppose that P of 23, so this one should tell you that we are talking about 2023 because t is 2000. So another thing that you need to note here is that now this here is like 2023, right? So that's basically what we are talking about here. So now what will be the interpretation for this? So we are going to say that here in 2023, because we have this one here. So in 2023, there are 200 people in the town, or let me say population, right? There are 200 population, right? Or we can say that, in short, we can say that, okay, 200 population. So in 2023, the number of people in the town or the population is the number of population is 200. So in 2023, the number of population is 200, or there are 200 people in the town. Any of them is fine. Now we are looking at the change. What is basically happening here? So as the population is growing, we get to 2023. We want to look at what is basically happening. But this is positive. So something positive means that, it's going to increase, right? It's going to increase. So how are we going to say this? So in 2023, the population of the town, is increasing by how many people? 5 per year. Per year is very important. It means that anytime we move from 2023 to 2024, the population is going to increase by 5, right? Good. So that's basically what is happening here. So when I move from 2023, so let's assume that I have a graph. This is 2023. We can see that the function is increasing, and it got here, and the number of people in the town was 200. We are looking at just moving to 2024. What is going to happen? Because this is positive, it means that it's going to increase by 5. So at 2024, the population is going to be 205 at 2024. So it's going to increase. If this one was minus, then it's going to be decreased by 5. So we will move to 195, which will be 2024. But since it is positive, then this is going to be a positive value. It's going to increase the population from there per year. Now we want to use this and this to estimate the population in 2025. So this is a nice way to do this. So for us to estimate, I'm thinking of like equation of the tangent. So I know that this should be p of x minus p of x1 is equal to the slope p prime of x1, then x minus x1. This is what I'm thinking. Then I can write it this way, and then p of x1 plus p prime of x1, x minus x1. So this is what I need to get. So if I've forgotten, you can think of the equation of the tangent. That's why I wrote it that one for you. So now here, x is equal to what we are approximating, which is 25. And then x1 is what is given, which is 23. So this is going to be p of 25 to be equal to p of 23 plus p prime of 23, then 25 minus 23. So what are we going to get? This will be equal to p of 23 was 200. P prime was 5. Then when I subtract this one, I'm going to get 2. So this is going to be 200 plus 10. And this is 210. So the population will be, estimation for 2025 is going to be 210, because this one should even tell you that, as we said, if the population is going to increase by 5 per year. So looking at what we have, we know that in 2024, we are going to have 205, as I was drawing the graph. And in 2025, it's going to be 210, which is nice, estimation. Like, it's very, very nice estimation to do here. Good. So that was question 8C. Question 8C. Now let me look at this one. So let me try and clean something and then put something here. Okay, so let me move this one up here. Good. So now let's look at question 8, question 9, then we look at the 10, then we close. Now, f of x is continuous on the interval this, and then f of 0 is this, and then f of this is this. Which of the following value is the... Okay, so this one is the intermediate value theorem. So intermediate value theorem, here we see that we want c to be between x is equal to 0 and s is equal to 2. So this is the quick way to find the value of c. So c is between 0 and 2. So I'm going to pick the function on it. So find the value of 0 and then find the value of 2. When you find the value of c, it's still going to lie between them. So this. Now the question is, what is f of 0? 7. And then what is the value of f of 2? F of 2 should be 1. So the value that's going to be between 7 and 1 is going to be, so that's basically what we are looking for. We want to look for the value that's going to be between them. So the value that's going to be between 1 and 7 is probably going to be B. It's going to be 3. Yes, so that's basically what we are going to get from here. All right, now let's look at B. If the equation of the tangent to f of x at s is equal to this, what is this? Oh, this is kind of very simple. Is anybody seeing what I'm saying? So this is just this, because the slope, this is mx plus c. So m is this. So this is in the slope intercept form. So my m is the same as this, and then I get it that way. So it's kind of like looking at this way. Now our x1 is 3. So we have y minus f of 3, which is equal to f prime of 3x minus 1, x minus 3, right? So when you simplify it, you have y is equal to f prime of 3x minus 3 f prime of x plus f of 3. Is that right? Yes. So the slope is always here. Okay. So this is just A. Now let's look at this one. Find limit as x is approaching pi on 2. So using the squeeze theorem, since we have f of x here, we have f of x here, we just need to take the limit through this. Then we are done. So limit as x is approaching pi on 2 of cos of x less than or equal to limit as x is approaching pi on 2 of f of x less than or equal to limit as x is approaching pi on 2 1 plus x minus pi on 2 squared, or in parentheses. So what is happening here? I'm just going to set x is equal to pi on 2 and x is equal to pi on 2 because we can do direct substitution. Plug it in. Cos of pi on 2. Now the question is, what is cos of pi on 2? Cos of pi on 2 is, I think, is 0. So this is 0. Less than or equal to limit x is approaching pi on 2 f of x less than or equal to. Now when I plug this one in, I'm going to have 1 plus pi on 2 minus pi on 2 squared. Now pi on 2 is going to be 0, so it's going to be 1, so this is equal to 1. So the left is 0, the right is 1. So the limit does not exist. So the best option that we need to choose here is the limit does not exist, because the left and the right are not the same. Okay, now let's look at the last question, then we are done, right? Let's look at the last question, then we are done. So a kite held by a person on the ground is flying at a constant height of 10 meters above the ground. The string is being let out as the kite moves horizontally away from the person at a constant rate of 5 meters per second. When the kite string is 50 meters long, the kite is 30 meters horizontally from the person. How fast is the string being left out? Okay, so let's assume that I'm standing here. Okay, I'm using myself, so let me draw myself to be nice. Good. So I'm here, and I have the kite somewhere here. So I'm holding the string to the kite. No, this is so bad. Good. So this is the, I think, let me just do this one well. So I'm holding this one like this. Good. So I'm holding the string, and then the question started saying that this is moving in the constant height of 10 meters above the ground. So from this to the ground is 40 meters, so 40 m. So I can now form something called Pythagoras theorem, like the triangle like this. Now, as soon as I know one side, I don't need to even read further. Then I can say that this is, let me say, x, and this is y. So as soon as I get something like this, I can use two unknown and one known to form the equation of the, this question. So using Pythagoras theory, I'm going to have x squared plus 40 squared is equal to y squared. So this will be my equation. Now I need to read further to know what is inside the function. So the kite is, flying at constant height of this above the ground. The string is being left out as the kite moves horizontally away from the person at a constant rate of 5. So constant rate of 5. Remember, this constant rate here is moving horizontally away from the person. So moving horizontally away from the person is this. And this line is this line. So it means that here the x over the t is equal to 5. Good. Now, what is the kite string? When the kite string is 50, so this is 50, so y is equal to 50 meters, and the kite is 30 meters horizontal from the person. So this is x horizontal from the person. So x is equal to 30. Then definitely we are going to calculate for dy over dt. Good. So all the information is out here. So now we are done. So this one, we don't need to even use the Pythagoras theory to find one of the variable, because all of them is given, x is given, y is given, and we just need to differentiate this. So let's take derivative with respect to t. X squared plus 40 squared is equal to d over dt y squared. So this is going to give us 2x dx over dt. When I differentiate 40 squared, I'm going to get 0. Then when I differentiate y squared, I'm going to have 2y dy over dt. I'm looking for dy over dt, so I'm going to divide through by 2y and have this. So now this is going to give us x over y dx over dt. So x is here, y is also here, and dx over dt is also here. So x is 30, y is 50, and dx over dt is 5. So 5 goes here 1 and goes here, is it 25? No, goes here 10, and then 10 goes here 3. So this is going to give us 3. What will be the, is it per seconds? Okay, let me see. This one will be 3 meters per seconds. Let me see what it is per seconds. Let's see. Okay, per seconds. Okay, so meter per second. So this is what I'm going to get for question 10, and this is the end of the video. And yeah, all the best.